Hello everyone, this is Mrs. Billig. Today we're going to learn about precision and measurement and how to calculate using significant digits. This is a skill that you will learn a lot more when you get into high school science classes, especially chemistry and physics. Your learning goal is to be able to identify the number of significant digits, I'm going to abbreviate as SD, and round calculations using the correct number of significant digits. So first of all, two very important vocabulary words, the difference between accuracy and precision. So accuracy measures how close results are to the true or known value. For example, if we were to have someone in the class and everybody tries to find the height of this person, say using a meter stick, and everybody gets different calculations. The person who is most accurate is the person whose calculation is closest to that actual person's height. Precision, on the other hand, measures how close the results are to one another. So if we found the average and how close those would be to the average, but not necessarily to the actual known value. When doing mathematical calculations or finding measurements that require rounding, a decision has to be made as to how precise that answer must be. Here's an example. The length of a room is measured by 3 different people. The measurements are taken as 6.8 meters, 7 meters, and 6.76 meters. Which of the calculations are the most precise? So precision here is determined by the number of significant digits or the number of significant figures in the measurement. So 6.8 has 2 significant digits. 7 has 1 significant digit. And 6.76 has 3 significant digits. The significant digits are the number of digits that determine or that account for that number. So this one has 3, and the one with the most significant digits is the one that is most precise. So in this case, the 6.76 would be because it has the most number of significant digits. There are several rules for determining the number of significant digits in a number, especially when to count zeros. The first and easiest rule is that anything that's not a 0, 1 through 9, is considered significant as seen above. So none of these are zeros, they all count as significant. Zeros that are between any non-zero digit are also significant. So 2034 has 4 significant digits because the 0 in between the 2 and the 3 count. 3.0005, since the 3 and the 5 count, the zeros between them count. So that would have 5 significant digits. Any 0 to the left of the first non-zero digit are not significant. This would happen if you had a decimal. So anything that comes before the decimal and before the last non-zero digit. So 0.005. So since 5 is the first non-zero digit, anything to the left of it or before it, so the left meaning before it, does not count. So it's not significant. These are called leading zeros. They just tell you what place value your first significant digit is at. So this would only have one significant digit, only the 5. These zeros don't count. And then 0.036 is another example where the zeros before the 3 do not count, but the 3 and the 6 do. So this would have 2 significant digits. Any zeros at the end of a number that contain a decimal point are significant. They are called trailing zeros. And trailing zeros mean that we are rounding to the precision of this certain decimal point. Like our measurement system was able to round to the nearest hundredth or thousandths or 10,000ths. So 3.0 has 2 significant digits. This is different from just saying 3. So if I were measuring something and you said 3 versus 3.0, that means it is exactly 3 on the dot to the nearest tenth. But this is less precise because you don't tell us what the decimal place is. Is it exactly 3 or are you rounding? You have to, this is just rounding to the nearest tenths, but this is rounding to the nearest tenths. Sorry, this is rounding to the nearest ones. 0.0250. So the leading zeros do not count, but the trailing zero does, as well as the 2 and the 5. So this has 3 significant digits. How about this one, 800 point? So that decimal point tells you that it's not just 800, it's exactly 800. So that means since this is a decimal point, these zeros count. So there are 3 significant digits here. If you have 800.0, that means I'm rounding to the nearest tenth. So that would have 4 significant digits because this zero would count because it comes after the decimal point. These are all trailing zeros. Since there's a decimal point and they come after the 8. Now let's look at the example where you just have 800. So for 800, there's no decimal point, so these 2 zeros are not significant. So it says zeros at the end of a whole number that does not contain a decimal point are not significant. So this only has 1 significant digit. These are what I call placeholder zeros, as well as the leading zeros are called placeholder zeros. This is just keeping the 8 in place of the hundreds. Another one is 102,000. There's no decimal point, so these placeholder zeros do not count, but the 0 in between the 1 and the 2 count. So this has 3 significant digits. And then finally, when numbers are in scientific notation, disregard the power of 10 and use the above rules on the decimal number only. So if you have 3.8, times 10 to the whatever power, you know that this just look at the number. So this has 2 significant digits. There are no zeros, so you just count the 2 digits. 3.08 times 10 to the whatever power. This would have 3 significant digits because the 0 in between the 3 and the 8 count. And if you had 3.080, this 0 counts because it's in between the 3 and the 0. This 0 counts because it comes after the 8 and it's in a decimal. So this has 4 significant digits. And this is saying if this is in also scientific notation. Okay, so now we know how to count the number of significant digits. Now we are going to apply that with the rules for multiplying and dividing, adding and subtracting with calculations. This says to determine the number of significant digits in your final answer when multiplying or dividing, first just do the calculation. Then, with multiplying and dividing, you're going to round your answer to the same number of significant digits that is in the number with the least number of significant digits in your calculation. So you want to choose the one that is least precise and base your rounding on that number of significant digits. Let's do an example. Convert 116 pounds to kilograms. Use the approximation 1 kilogram to 2.2 pounds. So we're going to take 116 and we're going to divide it by 2.2 pounds. And you'll get 52.72, repeating 7272. So then we will look at which of these numbers has more significant digits. Well, this one has 3 significant digits, and this one has 2. Remember, we're going off of the one that is least precise. So you're going to choose 2 significant digits. So round 52.72 to 2 significant digits. That would start with the first digit, 1, 2. So you're going to round the 2 and you round it up because the next number is a 7. So 53 kilograms. Next, a child measures 25.75 inches tall. Convert this to centimeters. We're going to use the fact that 1 inch is roughly 2.54 centimeters. So we'll take the number of inches, 25.75, and then multiply it by 2.54, and you'll get, I shouldn't use the squiggle until we round, you'll get 65.405 centimeters. So which number is less precise? Which number has the least number of significant digits? Well, this one has 4 significant digits, and this one has 3. So that means we're going to round our answer to 3 significant digits. So this would be 65.4. 1, 2, 3 round. You don't have to round it up. With adding and subtracting, you look at the number with the fewest number of place values. Round your answer to the same number of decimal places as the number of calculations with the fewest decimal places. So if you look at these 3 numbers, which of them has the fewest decimal places? Well, this goes in the second one, 1, and then 3. So you round it based off of this one. So we're going to round it to the nearest tenths. So this would be 10.3 feet. So notice we're not working with significant digits here. We're just working with place value when you're adding and subtracting. For example 5, you have 2.5 minus 1.268 is 1.232. This number is to the nearest tenth. This number goes into 3 decimal places, so we choose this to round because remember it's about the least, the fewest. We can't give a calculation that's more precise than our least precise measurement. That's the idea behind choosing the least precise measurement here. So that would be 1.2 liters. Okay, so now you're going to go to the 1.6 exit ticket in Polaris. You have an activity packet that has extra practice problems that would be good to study for your upcoming quiz. And then you also have the 1.6 Edulastic homework. Okay, but that is the end of that lesson, and I hope you have a great day.